Okay, so in the first part, we solved the problems, SQL problem related with the select statement. And now we are moving into the basic join problem in SQL. So we are still doing the SQL50 challenge question set. Before jumping into the question, first I want quickly look at with you how the join statement function, works in the SQL. To do so, I will show you the Venn diagrams. This is the best way to illustrate the easily and to get the idea behind this join, 4 different joins that we have in SQL. So we have 4 different type of joins. We have the join, or another name is inner join. Both statements return the same value, same records. Then we have left, right, and full outer join or full join. So inner join, as the name suggests, we get the records that have matching values in both tables. So this is the overlapping part here. And then we have left join. As the name says, so you take your left table as it is. So in our case, the table 1 here. Then you only take the matching records from the right table. Then for the right join, it's all the way around. This time you take completely as a whole, you take your right table, which is a table 2 in our case, and you only take the matching records, the records that exist both in the table 1 and table 2. So the records that exist, which exists in table 2 and also exists in table 1. So the match records from the left table. And the full auto join, so you return all the records where there is match in either left or right table. Okay, so let's have a look how does it work in the real SQL problem. So we have a problem replace employee ID with unique identifier, which I opened it here. So what we have here, we have employee table, employees table with a column name, ID and name, integer and character variable, and a second table name is called employee unique. So here we have ID and unique ID, which is a primary key, and we have each row of the table contains ID and corresponding unique ID of the employee in the company. So we have to write a solution to show the unique ID of each user. If the user doesn't have unique ID, we have to replace just to show null values. Okay, so here's a given example. We have Alice, Bob, Mayor, Winston, Jonathan with their corresponding IDs, and employee unique table, we have IDs and unique IDs. As we see, Alice with ID number 1, it doesn't have any corresponding unique ID. So here basically when you join this table, so basically if you do left join, it means that on the left we will have the employees table here, and since there's no matching record on the employee unit table, so we will have a corresponding value of Alice and Bob here and null values, so there's no existence. And for the mayor, Winston, Jonathan, as you see it here, mayor is 11, it has a unique ID 2, and Jonathan is 3, it has unique ID 1, and Winston is here 90, and it has unique ID of 3. Okay, this will be our result. So how do we do it then? So we do with select statement, since we have 2 different tables, and in SQL, how do you select the corresponding column within a specific column? To do so, you can use a dot sign. So for example, if we give our employees table name as of for example E, let's say, and other table we call it EU. Okay, So if I want to choose, because my first column is in output is a unique ID, so I'm gonna say that EU dot unique ID. So this will return me the unique ID of the column employee uni, because I gave it name as a shorter for better readability as alias EU. Then to select the name is the columns that comes from the employee table. We do it same, e dot name from our table employee unit table. Okay, or actually, okay, I will show you two different way. First we will do it left join, and then we will do it with a right join. So when we do it with a left join, so it means that in the left I will keep my employees table. So first I will select from the employees. Okay, so we gave it as E. You can use either AS E, or you can simply use E, because AS stands for allies. You don't necessarily have to write it down. And then we will do left join, because as I explained earlier, here idea is that I want to have everything from my left table, so I want all the names here. And as we said it here in the left join, we keep everything from the table 1, the left table, and only the match records from the right table. So in our given example, the match records will be, here's the one existing in the employee unit table, which is Mayor, Winston, and Jonathan. That's why we will say the left join our second table, which is employee uni. Okay, we're gonna copy paste, and we give this table the alias name of EU, and then we have the on statement. So here's the corresponding columns that existing in both tables are the ID. So it will be e.id equal to eu.id. Since actually there's no requirement in terms of the return, so we can simply end our query here. Let's check it out if it works. Okay, so we have output and expected is the same. The second way that I wanted to show, how can we do it with this time with the right join instead of left join. Okay, so to do so we cannot do a slight changes. This we keep it as it is, so there's no need to change it. And this time, instead of selecting from the employees table, we're gonna select it from the employee unit table, because in the right join we say that okay, we take the table 2. In our case, the table 2 will be employee uni, and we will take the match records from the left table. Left table in our case will be the employees this time. Okay, so we say from employee uni, which we gave the name EU, then we say right join employees E on e.id equal to u.id, and that's all. So let's run it out. Oh, actually we have to delete that one, because otherwise it's not gonna work. Okay, you see it's worked as well. So both are the same. We did the slight changes, and that's all. The result are the same. We can actually submit it. Okay, yeah, it says it's on the file, but we are not really concerned about it. We have been provided with two tables, sales and the product. And idea is that we have to write a solution to report the product name, year, and price for each sales ID in the sales table. So this is a very easy question to solve. So we have to join these two tables and select the required columns as it says here. So we start with a select statement. So the tables, the columns are required is the product name. Product name comes from the table product, what we will call it P dot product name. Then the second column that we need is the year. Year comes from the table name sales, what we will call it this S. So S will S dot so it's gonna be S dot year. Then the last column is the price that comes from the table sales again. So S dot price. Just want to see, yeah. From our table, let's start with the sales. As S, that we gave abbreviation S alias. Then we do a simple join, inner join. Join is a second table which is called product, what we call it P on. So our the product ID is the column that's shared in both tables, so we will do it on the product table. So S product ID S dot product ID equal to P dot product ID. Since there's no requirement about like ordering, so we will leave it as it is. We just close our query with a semicolon and we run it. Okay, so it passed the test and we can submit. Okay, let's go to the second problem. Customer who visited but didn't make any transaction. So here we have again two tables, visits and transactions. Okay, the table contains information about customer who visited the mall. The table contains information about transaction made during the visit ID. So we have to write a solution to find the IDs of the user who visited without making any transaction and the number of times they made these visits. Okay, so here we have to do join as well. So idea is that we need to get as in the example. So we have visits customer ID. So ideally we need to have all the customers ID from our visit table. But if let's think if we do a left join, we will have all the corresponding values from here, but only the matching values from the second table. So it means whenever there is a visit ID but there is no corresponding transaction ID, so we will get the null value. So this is what we are interested in actually, and we have to count number of this let's say non-existing transaction ID. So how to solve this? So to do so, we have to start selecting first our customer ID column, which comes from our table visits, what we will call it V for shorter and better readability. So we will do select v dot customer ID. Then so we need to have count non-transaction. So it means that we have to use a count function. So here you can either put count in the brackets v dot customer ID, or you can put the asterisk, which will go through all the values to count the customer IDs with a non-transaction. And we have to give it a name as it is here, count non-transaction. So count asterisk, we can give it S like alias count non-transaction. Then so we will select first from our visit table. So in the left join, so basically our the first table which will stand in the left is gonna be visit. So visits with the S at the end. Then we do a left join. Left join on the second table, which is called transactions, which we call it ST, let's say. On, so our shared column here is the visit corresponding column in both tables are the visit ID, so it's gonna be v dot visit ID equal to t dot visit ID. Then so we have to also filter, because what we are interested in here to get the IDs of the customer who has made no transaction. So basically we have to choose the column, the values corresponding with the null values. So it means we have to use a where statement. So where t dot transaction ID is a null value. Okay, so this is important. And since we are using, just also remember, so this is also a commonly asked question in SQL interviews, like when do you use a group by and order by? If there is an aggregation function such as count, sum, then you have to use a group by, not order by. So what we are going to do here, and it also comes after the where statement. So first you use your aggregation, then you use a where for the filtering, and when you finish with the filtering, at the end you have to do the group by. So we need to group by customer ID. So use group by customer ID from the visits table. So v dot customer ID. So again, to sum up what we did here. So here we are selecting the customer ID and counting number of visits without transaction. From visit we start with the visits table and we give it alias SV. Actually I forgot to note here, you can note as or just without as, you put the V. And then we use a left join. So left join helps us to include all visits even if they don't have a corresponding transaction. Okay. Then by using the where statement, so we are gonna filter. We are going to filter transaction where the transaction ID is a null. And at the end we use group by. This groups the result by customer ID, so we get count for each customer. Let's run it. Okay, so that's perfect. So, hi everyone, today we are continuing with our LEETCODE Top SQL50 question series. So we will be doing a problem about the rising temperature. So here we have been given a table called weather. So we have ID, record date and temperature table, integer date and integer. So ID is a column with unique values for the table. There's no different rows within the same record date. So it contains information about the temperature on a certain day. So we have to write a solution to find all dates ID with higher temperatures compared to its previous days, like yesterday. And we have to return the result table in an order, okay, and result format is in the following example. So we have the dates here. In 2015 is the month of January, 1st, 2nd, 3rd and 4th January. So we have the temperatures here 10, 25, 20, 30. So here we look, so this is like okay, we have to make sure the record date is the one comes after another one. So this is like a previous day, and this is, for example, today, and again this is a previous day today, and the temperature 30 is higher than 20 and 25 is higher than 10. So our output is gonna be ID. So this SQL is classified this problem as easy, but I mean, I wouldn't say it's an easy problem unless you know how to use the dative function or lag over function to find the record from the previous day. So basically what we have to do is that we have to join this table with itself, or we can call it make a duplicate, a copy of the exact same table and compare the records. So to do so, first we start with the select statement. Let's say we're gonna call it differently. First we will call it weather1, like with the shorter w1 and w2, the second copy. So basically the w1 will correspond to the dates with the higher temperature. So let's say we call w1. So since we need to have the IDs at the end, we will do w1 dot id. So from our table called weather, so the first we called it weather1 w1, and then we will use a join function. So we will join again with the same table, but we will call it differently, weather2 as v2 on. So we will so here gets interesting part. We have to use a dateDiff function. I will explain you exactly at the end. So we open the brackets. So since we said that w1 is a table where we have the higher temperature, so we will put in the beginning. So we will be putting w1 dot record date, and then we put the second table w2 with a smaller record date. So it's like a previous day here, for example. and the difference between these two should be equal to 1. And we have second condition that so the W1 temperature should be bigger than the W2, so it means that we have to use the where for filtering. So we will put W1 dot temperature. I did a mistake here. Okay, should be actually bigger than W2 dot temperature. Since there is no special requirement about the ordering, we will end up our query. So to explain you from the beginning, so we used here select w1.id because we are selecting the ID of the days with a higher temperature. So this is our table weather 1. So we start with the weather table and we give it the alias, the shorter name, and w1. Then we use the join function here. With the help of the join, we are actually joining the weather table with itself, and while we use the date function, the idea behind it is that this function calculates the difference, okay, in days between 2 days. So we are looking for rows where the difference actually is 1, okay. So difference is exactly 1 day, which means that the table 2, like a second copy, which we called it a V2, actually they represent the previous day. So here this is V2, this is V1. So this is previous day, this is, for example, the current day of today, we can call it. And by doing a where w1 dot actually here there's a spelling mistake. By doing that, this condition helps us to make sure that we only get the rows where the temperature is higher from the previous day temperature. So why we are getting the error? So join weather dative. Oh, here we have actually a mistake, so it should be dot. Let's run it again. Okay, perfect. So problem number 1661, average time of process per machine. So we have been given an activity table. So activity table provides us with the 4 different columns: machine, process, activity type, and timestamp. Here we have a factory website that has several machines, each running the same number of process. So we have to write a solution to find average time for each machine takes to complete the process. So basically there's a table. As you see, there's a machine ID, and each machine ID has two different process ID, which is 0 and 1. And this comes with a start and end activity type. And to find the processing time, so what we do is end minus start ID for the process ID 0, and we do the same process ID number 1. We adding summing up the result and dividing number of process ID. Okay, nice. So to solve this problem, we will be using a self join. Because if we're gonna use a self join on activity table, which will allow us to directly pair here's the start and end records for each process. Okay, to start with, we will use a select statement. So we will select we need as a machine ID processing time as given in the example. So once we will call our table A and the second soft copy we will call it B. So we will use a dot machine ID. Okay, to find this average time, processing time, we will use the function name average. It's avg. So we will use the difference between two timestamps. So this, okay, let's say the second table is comes with n, so we will call it with the b. So it means b dot timestamp minus a dot timestamp, and so this will give us average. But since there's also a requirement that we need to round the result to the 3 decimal place, okay, to do that we have another function called the round. So we open the brackets here, and to 3 decimal place it means use comma and 3, we close the bracket, and we call it we will give it the name processing time. So s allies processing time. So from our table name was activity, first we call it activity A, then we will use a join or inner join on again activity table, but this time we call it B. So in order to join, we have several join conditions. The first should be the machine ID, and second will be the process ID, and which will help us to make sure that we are matching the correct start and end time for each specific process on the machine. And these are the primary keys, including the activity type. So let's start. Activity B, then we will use on. So first it's gonna be a dot the machine ID equal to b dot machine ID. Then we use and to add the second condition. We said it's gonna be process ID, so a dot process ID equal to b dot process ID. Then the third one, we need to define the start and end for the activity type. So here we did the b minus a timestamp, so it means that the b stands for the end, a stands for the start. So it means a dot activity type is equal to the start, and we have b dot activity type equal to the end, and that's all. So at the end we need to use a group by, because we want to get the separate result for each machine, and also we don't use order by because we have an aggregate function here. So we can use a group by machine ID. Okay, perfect. So we are solving the problem number 577, employee bonus. So we have been given two tables. One of them is employee table with the 4 different columns, and the second one is a bonus with employee ID and bonus. So here we have been requested to find a solution to report the name and bonus amount of each employee with a bonus less than 1,000, and okay, return the result in order. So this is our employee table, bonus table. This is the output, expected result. So we should have a name and bonus column. Okay, interesting. So we also get the null values as the result. So it means that our condition should be less than 1,000, or it should be null value. So we have to choose both. Okay, let's start. So we need to have name and bonus. So we will start with the select statement. So for the name, we are taking it from the employee table. So we will give it the name E for short. E dot name, and the bonus we will get from our bonus table. So we will give it as a B, alias B dot bonus. So from our so basically we will do the left join here, because we need to get, the idea is that to get all the names, everything from the employee table, and only the corresponding values from the bonus table. So it means that if there is no like a bonus employees that who doesn't get a bonus, so basically it will be null corresponding values, and after with the filtering we will get the required values. So basically we will do it from employee table, then we do a left join, and with the bonus. So here we will add E, which I gave it, and bonus SB on. So our common table column name is employee ID, so it's gonna be E dot equal to B dot EMP-ID, and here should be where our B dot bonus should be either less than 1,000. Let's get back less than 1,000. In order to get the null values, we should use the OR keyword, or B dot bonus is null. Okay, perfect. Okay, now we are solving the problem number 1280. So it's called students and examinations. So we have been given students table, subjects, and examinations table, and we have been requested to find the number of times each student attended each exam. Okay, here's an example. Okay, student ID, student name. Okay, so for example, student ID name here, which corresponds to student name Alice. So we have seen she has attended the math exam, for example, 1, 2, 3 times. Okay, I see. So let's start with our select statement. Then we will think about the rest in upcoming minutes. Okay, let's start with the select. So we need student ID, student name, and subject name. So student ID and student name comes from the student table. So we will give it to the shorter name of S. So it will be S dot student ID. So we have to use a comma, otherwise it will not work. So then second we need student name. again with a comma. Then we need the subject name. Subject name comes from the subjects table, so we will give it the shorter name of sub dot subject name, again comma, and we need to get attended exams, so the counting how many times each student attended, for example, math and physics. So you see these are the repeated value, the subject name. So here we just use sample count function because we don't need to use distinct because we need to take into account all the counting for each subject name. Even so it's repeated, so we will use a count. So we will use a count, so we will count it from the examination table. So it means we will give it the shorter name of E. So E dot subject name. Oh, actually, there's a spawn. Or we will correct it. Subject name. So it will be called as a new column attended exam. So Alice attended an exam. So from our table name students, from students, which we gave it as S. So here now comes the interesting part because as you see, the idea is that we need to combine these two tables to get the corresponding values. But here there's no common shared column name such as student ID or which exists in both or student name or subject name. So what we can do is that to get like every combination of student and subject, we can use the cross join. So the cross join, it will create us a row for every combination of the student and subject, which will help us to get all possible student-subject pairs that we need. Even so, the student hasn't taken any exam in a particular subject. So what we will do, we will do it the cross join. Let's say cross join the subject table, which we gave it the name as sub. Then secondly, we need to use another function, join, because now we have the third table examinations and we need to do combine, to join. So that's why we will use this time a left join, because with the help of left join we have so idea is that we keep the in one part the students table, so we get all the records from the students table, then we get the corresponding columns such as student ID from the examination table, and we also gonna combine join it with the base on the subject name which has here and here. Okay, so let's do it then. So we said left join with the examinations we gave it as a name E on. So starting with the students table, we say student ID from here, we have it, and here. So then means S dot student ID equal to E dot student ID. So then we use AND keyword to make a join on the second condition of the column name of subject name. So it means sub dot subject name. We're gonna make it like this. So subject name equal to e dot subject name. So basically, again, I repeat, by doing the left join this time, the left join with examination table, we keep all student subject pairs, okay, from the step 1, which is here, that we get from the cross join. Even so, there is no matching records from the examination table. So then we need to do the group by and order by, because first group by we use group by because of the aggregation functions that we used earlier in the select statement. So we need to group by based on the three columns: student ID, student name, and the subject name. Okay, so let's say group by is s dot student ID, comma s dot student name, then the subject name, which comes from the subject table, sub dot subject name. Then we're gonna use order by. This time we will order by users. So we have it as a ascending order, student ID and also student name. So basically we will say s dot student ID, comma s dot student name. Okay, let's run it. Perfect. All seems good, expected, and output. Okay, perfect. Okay, now we are looking at the problem number 570, managers with at least 5 direct reports. So we have been given an employee table with 4 different columns: ID, name, department, manager ID. Okay, ID is the primary key. Then we have to, okay, each row in this table indicates the name of employee, department, their ID of the manager. So ID manager is null, so it means the employee doesn't have a manager. Okay, so no employee will be the manager of themselves. So we have to write a solution to find the managers with at least 5 direct reports. So return in any order. So basically we have employee names here, and these are the manager's ID. Okay, so the John has a null manager ID because John is already manager of 5 different other employees. Okay, so he cannot be manager of himself, and this is the output. Okay, so all the problems are listed here. You can have more than one solution, but the idea behind is that we always try to get the simplest solution, not very complicated. Like in SQL you can do many stuff with the Windows function, CTA, common table expression. But if you can achieve your result, the requirement, in a simple solution, then in terms of time and memory complexity is also efficient for you. So here the idea is that we're gonna use 2 different methods to solve it. The first we will look at the subquery, and secondly I will show you how we can do it with the self-join. Okay, let's start with the subquery. So what do we mean with the subquery? So subquery, actually you have two queries. One comes inside another one. So basically you have the outer query and you have the inner query. So start with what we need first of all. So we need to get the name of the manager. Okay, so that's why we will start with a select statement. Okay, So we will select name from our table name employee. And here it comes the stuff. So the first, we select the name of the employees where the ID match the IDs of the managers that we will find in our subqueries. So here what we do is that we have to filter the IDs. To filter it, we're gonna use the where statement. Okay, so where ID in, we're gonna use the keyword in, and from here starts our subquery. Okay, so we open the brackets. So the idea behind the subquery is that so the subquery gonna group the employees by the manager ID. That we have it here. So with the help of this, what we are going to achieve is that after grouping by the manager's ID, and then we're gonna start counting how many employees, how many employees each manager has. Okay, so here, so the having clause, we're gonna use the having. Is a special keyword that helps us to only include the managers with the 5 or more direct reports. So it means 5 or more employees. So to do so, again, we start with our select statement. Okay. So we use select manager ID. Okay, again from our table name employee, and as I told earlier, we're gonna group it by manager ID. So group by manager ID, and we're gonna use having. The important here, important message to keep in your mind, so it's because it comes also very often in the SQL interview question, what's the difference like between having and where, when you can use having but not the where statement, because both are used for filtering. So if you use a group by, then you have definitely use having, you cannot use a where statement. Okay, so keep in mind. And also you can have both a group by and order by in one select statement. The ordering is that first you need to have a group by, then you need to have the having to filter, then you can use the order by. So order by, it comes at the end always. But if you use only order by and where, so basically you have to first filter, so it comes so first you need to have the where statement, and then you can have the order statement. So the having, so we're gonna use the count, because we have to count number of employees each manager has. So basically we're gonna use the count. Then it is bigger and equal to 5. Okay, so then our subquery ends here. We're gonna just add the semicolon and we're gonna run it. Okay, then we look at the second solution here. We said we're gonna use a self join. So what are we going to do here? So we're gonna use again a select statement. So we're gonna use a select. So first we need to select our name column. So basically we will have, so when we do a self join, so with the same table, we're gonna call it first employee, and we give alias E. So, and when we select the name, we're gonna do as e.name. Okay, so from employee that we gave as a E, then we use the join statement. So what are we going to join? So we're gonna join with itself, the table itself. We're gonna call it this time differently. Let's give it alias M. So what we have to do is that we need to join ID column here with the manager's ID column here, because what we are trying to achieve is that we are when we're going to join the employee table itself, so we're gonna match each employee with their manager using the manager ID. Okay, so basically we're gonna join. So we got on. So what we do, E dot manager ID equal to the M dot ID. So we take the manager ID from the employee table first, what we called E, and from the second employee table we're gonna take again, okay, one we take the ID, and the second table we take the manager ID. Okay, so then we're gonna use the group by function, so because we need to group both the manager ID and the name. So you use the group by, so m.id, and then we use m.name, so manager ID with the manager name, and then we're gonna again use the having function, having count. So we're gonna filter the group to only include those where the count of employee is 5 or is a more. Okay, so again, having count, so inside the count we're gonna add the e.id because we are interested with the employee ID, bigger and equal to 5. Okay, and yeah, actually, since there's no requirement in terms of the ordering, we can actually end our query here. Oh, we did actually a mistake here. Oh, actually, I have to put okay, here's the thing. I need to select the name. So m.name. Okay, yeah, because we need the manager name, and we're gonna filtered by employee ID, because here I grouped by the manager ID and manager names. That's why it was wrong first. Okay, so basically, to make it correct, then it's gonna be M here. The second one we're gonna call E. Okay, yeah, this one is much more better. Okay, we are looking at the problem number 1934 about the confirmation rate. We have been given two tables again, sign-ups table that have a user ID and timestamp columns, and we have confirmation with user ID, timestamp, and action. Okay, so user ID is a column of unique values for the table, and again here user ID timestamp is a primary key. So what do we have here? So we have the confirmation rate, which says here of user is a number of confirmed messages divided by the total number of requested confirmation message. And then we have confirmation rate of users that didn't request any confirmation messages, which is equal to 0. And we have to round the confirmation rate result to 2 decimal place. So write a solution to find confirmation rate and okay, result table in any order. Okay, so here you have signups table and confirmation table, and this is output. Okay, let's first look at the user's ID, which has the confirmed action type of confirmed, because it's much more easier to understand. Here we have user ID of 7, which has 3 different messages, timestamp with the action confirmed. Okay, so it means that okay, so user ID 7 made 3 requests and all were confirmed. Okay, as we see it here. So confirmation is 1. Okay, how do we calculate it? So we take number of confirmed messages, which is 3, divided by total number of requested confirmation message, which is 3 as well. So 3 divided 3 gives us 1. About the user ID 2, we have 2 messages in total. One is confirmed, one is timeout. So it means 1 divided total of messages 2 gives us 0.5. Okay. So what about the users which has not any confirmation message? So which is the case for the user ID 6, which has no corresponding value in the confirmation table. And the user ID 3, okay, he has 2 actions, but it's a timeout. So basically these 2 are 0. So we have to do a join here, and we have to use the left join here because we want to get all the values from our left table, which is the signups table, and the corresponding values from the confirmation table. But here is the issue is that we do not want to get the null values for not the non-corresponding values, which doesn't exist in the confirmation table in terms of confirmed messages. So instead we want to get the 0 value. So here it gets more interesting. Okay, how can we not have null but instead replace it with a 0? Okay, we will see it how we do it. So as always, we start with our select statement. Okay, so basically let's see how do we do it. Okay, so we're gonna select our user ID because in our output first we have user IDs and the confirmation rate. Okay, so we start with a select. So first we take user ID. Okay, first our corresponding table of the signups, we're gonna give it for simplicity alias, okay, shorter name A, let's say. So A dot user ID. This is the easiest part. For the second part, okay, let's first look how do we do to get the average value for the action type confirmed. We say, okay, so it's number of confirmed messages divided by total number of requests. So in SQL, like in Python, we have an average function, okay? So average function exactly completes this required thing, well, like number of confirmed divided by total number of occurrences. So it means we use EVG, average, which stands for average. And here we are interested with action type confirmed. Okay, so it means action equal, since it's a string, we're gonna use a single quotes. So single quotes Oh, actually, we can also use a double quote. Yeah, it's the same, doesn't matter. Okay, let's use a confirmed. Okay, so it means with this we're gonna calculate the average for the confirmed message. But what about the case where we have no corresponding value? Okay, no confirmed and no timeout. Well, actually, timeout is also considered 0. So for this, we're gonna use if null function. Okay, so if null function, it's kind of how to compare it. Maybe in the Python we use true false or if else statement, you know. So these are special the, let's say, keyword or function which handles cases where there's no like confirmation attempt, so it's giving a default value to 0. Okay, so to do so, we're gonna add if null here. We open our parentheses, and so this is our first condition. When there's a, it's kind of a Boolean expressions, this one. Okay, so action when it's confirmed, so it's a Boolean that returns 1 when true, which is for our ID number 7 that we saw earlier, and 0 when it's false. So basically we're gonna do the same, which is false, and we're gonna add the 0 here. Then we close our brackets. Then we have another requirement from us. We have to round the resulting result to our 2 decimal place. So for that we have another function which is called the round. Okay, so it means we add the round in front of our if null statement. So basically okay, 0, and we close the brackets, we use comma, and we use it too. Okay, so it's gonna round the result to the 2 decimal place. Then what we need to do is that we have to give to this result a name which is required from us, a new column name, which is a confirmation rate. Just we're gonna copy and paste here. Then we use the from statement to choose it from the signups table, which we gave the shorter name A, alias. Then we use our left join. So left join from our table called confirmations, which we're gonna call it as a, let's say A. We use A, now we use a B. So on, we're gonna so join our tables based on the user ID, which is the unique ID in both table, and actually it's a foreign key in the second table. So on a dot user ID equal to b dot user ID. Then of course, since we have an aggregation function here on the first select statement, we're gonna use a group by, and we need to group by user ID. So use a group by a dot user ID. Okay, we don't need ordering because it says return the result table in any order. We run it. Okay, and we submit. Perfect.